Alright, so a few people wanted to be able to interact with 3D objects in augmented reality, similar to what you can do with the Microsoft Hololens. Without spending $3,000 on a pair of augmented reality smart glasses, we can do something similar with the Leap Motion and a Google Cardboard style VR headset. Today we're going to use Unity 3D and the Vuforia plugin to interact with 3D objects using our hands in AR and VR with the Leap Motion, a VR headset, and our mobile phone. Now, while I think fidget spinners are a pretty terrible trend, second only to the male rompers as of late, they do serve as a nice quick demo for this type of project because well, this is good because it ended up being a little bit more involved than I would have hoped. First of all, getting the Leap Motion communicating with your mobile phone is not the easiest thing in the world. It does not have Bluetooth or anything like that, and it only connects to your computer via a USB cable. So the only option we really have is to open up a socket and send positional and rotational data of the Leap Motion to our mobile phone via Wi-Fi. Now, we're not going to do this from scratch in this video because it would take too long. So I actually created a Unity project that we're going to use for this purpose. The project will allow us to build a server application that will run on our desktop, and it will send the data from the Leap Motion to our mobile phone. The project I created is only going to track the palm position and rotation, so it won't get fingers. So if you want a more full-featured solution, you can look into Color Reality by Tango Chen. This will run much better. Also, if you're interested in creating your own implementation, Jai-Hee Chen has done a great blog post on this topic. So I'll link to both of those down in the description below. Now, the only reason I did not use the Color Reality project in this video is because the desktop application, or the server part, only runs on Windows, at least for right now. So the newest Leap Motion SDK is also only for Windows. But if we use the implementation that I made in Unity with a legacy version of the Leap SDK, we should be able to get this working on Windows or Mac, and you should be able to build out to Android or iOS. So it doesn't matter what you're using, this should work for everyone. Now, in order to follow along in this video, you will need a Leap Motion, of course, a Google Cardboard style VR headset, and your mobile phone. So the Leap Motion can be purchased for about 80 bucks. And they typically come with like a dev kit, which has got a bracket that you can use to mount to your headset. I don't have that. I just have mine taped to my headset here, which works fine. And then your VR headset, this is just a little plastic guy I got on Amazon. It's about 10 bucks. But try to get one that has kind of a sliding window here so that it'll expose your rear-facing camera on your phone, because that's important. But I'll put links to where you can buy all this stuff down in the description below. Now, the first thing we need to do is get the Leap Motion tracking our hands on our desktop, just to make sure everything works. And then we'll get the hands showing up in mobile VR so that we can interact with some virtual reality fidget spinners. And then with a few extra steps, we'll be able to make the same project work in augmented reality, so we can play with some AR fidget spinners as well. This will give us the kind of like Hololens type of feel that we're looking for. So first, let's get the Leap Motion working. First things first, let's go to leapmotion.com. We're going to need to download the Unity core assets, and we need to download the Leap Motion SDK. Go to Developers, and then Unity. So like I was saying before, the main SDK looks like Windows only, Leap Motion Orion. But we want to go down here to V2 tracking. Click on this, and here's where you get the SDK. You can download this for, like I said, Windows or Mac. Doesn't matter, but download this right here. And then also, let's see, for Unity assets, okay, yeah, click here. And then we also need to download the Leap Motion core assets. So click Clone or Download, and download the zip. Okay, so we should now have these two folders right here. Leap Motion core assets and the Leap Developer Kit. So install the Leap Developer Kit, and it should give you a program that looks like this, Leap Motion. So we can open that, and let's go up here, and let's go to Visualizer, and let's just test and make sure this is working. All right. Nice, we've got hands. Okay, now that we've ensured that's working, we can actually quit that app. We won't need it for right now. And go to Google Chrome, go to github.com, and we're going to download my Unity project that's got this server application in it. And type in Leap Motion desktop server, I think. Okay, yeah, desktop server, Leap Motion, and Matthew Hallberg, that's my name. Click on this, and download this Unity project. Okay, so once this project is downloaded, drag it onto your desktop and unzip it. Okay, so let's open up this project. Okay, so first of all, in the assets folder, there's another folder called fidget stuff. This is stuff that we're going to use in another project. So drag this, put it on your desktop for now with your other things there. Now pull up hand control, and we're going to just want to change an IP address in here. So like I said before, this server application is going to send actually UDP packets through a socket to your mobile phone. So we need the basically IP address of your mobile phone here. So if you go to, at least on my iPhone, if I go to settings and Wi-Fi, I can see my my network, which is called Will Trade Password for Beer. If I click on info, it gives me the IP address of my phone. So in my case, it's 10.0.0.37. But make sure you just change this to whatever yours is. Now, once that is done, make sure that your computer is also on the same Wi-Fi network as your mobile phone. So now's a good time to probably check. So should be good there. Now we can actually test this in the editor. So if your Leap Motion is plugged in and you press play, we should be able to see hands on the screen here. Yeah, we do. So that's good. Now you'll notice whenever you build this out, whenever we get this working on a phone, you'll notice that there's a little bit of an offset between the actual like virtual hand and your real hand. So that's why I have all these buttons for like left X, left left Y, left Z. We'll have to use these later, and this will actually help us to correct the offset. But for now, just ignore them. And let's get this built out as a desktop application. So if we go to build settings, make sure you're on PC, Mac, Linux standalone, and we should be able to just click build and run. Looks like good resolution. Make sure it's windowed is checked, and let's click play. Now pull up your Leap Motion again, and yes, we got hands, so our desktop server part is completed. So close this for now, and let's go to File, New. How do we do a new project? New project. And now we're going to create the VR part of this. Okay, so before we do anything here, go to File, Build Settings, and change this to Android or iOS, depending on whatever you're going to build out for. Okay, once that's done, let's save the scene before we forget. Just call it main or whatever you want to call it. Now go to Leap Motion Core Assets, and we want to import the Textures, Materials, Models, and Prefabs folder. And then drag all these, it should be 4 items, into your Assets folder of your Unity project. Okay, so once that's finally done, we can start importing the rest of the stuff that we're going to need. So grab that fidget stuff folder that we got from the other project and drag that into your Assets folder. Okay, now go to Vuforia.com and download the Vuforia plugin if you don't already have it. Let's get your license key. Click Add a License Key, Development, blah blah blah, App Name, Fidget. Okay, so go to your license key and copy and paste this. And then let's go to Target Manager. And we need to create a image target database, because that's how we're going to be able to display those fidget spinners later. I don't know if you noticed, but I had an actual image target up on my computer screen whenever I was doing the demo for the intro. So we're going to create that now. So click Add a Database. It's going to be device, so let's call it fidget spinner. And let's go add target. And what we want is, there's a picture in that fidget stuff folder. So find that fidget stuff folder and fidget design JPEG. Open that, width, put 5, and let's add that. Okay, download this database for the Unity editor. Let's get this onto our desktop with our Vuforia SDK right here. And let's get both of those imported into Unity. So first drag in Vuforia. Okay, that's finally in there. So let's drag the fidget spinner image target database, drag that into your assets folder as well. Alright, let's change this to free aspect. Alright, so now that we've got everything we need, go to the Vuforia folder, prefabs, and drag the AR camera into the scene. We can delete the main camera. Go to AR camera and open Vuforia configuration and paste in your license key there. Now we want to change a couple things here. So go back here and change World Center mode to device tracking. And then open Vuforia configuration, and we're going to go video, let's see, hour type video see-through. We're going to do Vuforia, let's see, cardboard v1, load fidget spinner database, activate, make sure that's done or else this won't work for some reason. Okay, and then down here, model correction mode, change this to head. And then uncheck enable video background. The reason we're doing VR basically with Vuforia right now, I forgot to mention this earlier, but it's because Unity just introduced native VR integration into Unity 5.6, where you actually don't need a a VR SDK like the Google VR SDK anymore to build out. You can actually just change in your build settings. You can do enable VR mode. When I was going to do this video, though, I wanted to use the Google VR SDK for this, but it just did not work for whatever reason. At least on iOS, it's not working yet with this native integration and the Google VR SDK. So we're just going to do VR with Vuforia for now. Okay, so first things first, we can't see anything. We also need to get a skybox. So go to the asset store, and I like this Cope skybox pack. So let's just download that for right now. Cope Skybox, it's the first one, free. You think you get 3 skyboxes in there, so import that. My computer sounds like it's going to explode. I've put it through a lot lately. Okay, so once this is finally done, go to the Window tab, Lighting, Settings, and default skybox, change it to, let's go Mossy Mountains. And then go back to, go to AR camera and change this to skybox. So now we should have something to look at here. Now let's create a ground plane. So go 3D object plane, and let's just put like a darker material on it. So go to the materials folder and find some like dark gray, I don't know. That's fine, a little bit darker than that's good. And then let's make it a little bit lower than the camera. So lower this down to, let's go -0.8. Yeah, that's about good. Okay, so now let's create the game object that's actually going to instantiate and destroy our hands. So create an empty game object, and let's call it hand controller. And then let's drag that and make it a child of the AR camera. Okay, so go to the assets folder and fidget stuff. You should see a hand controller script in there. So with the hand controller game object selected, drag on this hand controller script. This is what's going to receive the UDP packets from our server app. So it's looking for 2 hand prefabs. So you should be able to use any of these, but if we go to assets, prefabs, and hand models human, I think I used these 2. Yeah. So pepper medium, cut left hand, and right hand. So with the hand controller selected, drag these both into their respective holes. So left hand goes there, and the right hand goes there. Alright, now we need to create our fidget spinner. So drag the fidget spinner OBJ onto the scene here. In the fidget folder, fidget stuff, it says Tinker. I don't know what that is, but drag that onto the scene. And we need to scale this down. So scale this to like 0.05 across the board. Okay, so move this outside of view. Move it out of the plane here a little ways, and we can move it up a little bit. Now let's make it look halfway decent. So go to the materials folder, or no, sorry, assets, and then materials. There should be a bunch of materials in here. Yeah, just drag whatever materials you feel like look good on here. I don't know. Now let's rotate it a little bit so it's easier to play with. So rotate it about the X a little bit, Let's go, yeah, -35, that looks about good. And then we need to do a couple things to get this to actually spin. So let's add a rigid body first of all. Uncheck use gravity, make the mass 0, change the interpolate to extrapolate, and on the constraints we only want it to rotate, I think it's about the Z, let me make sure. Yeah, check all of these and leave the Z rotation unchecked. So everything's frozen except for the Z rotation. Alright, now we need to actually add some box colliders to this in order to be able to interact with it with our hands. So change the size of these box colliders, maybe go like 10 or something just so we can see them, and then you should be able to drag these little boxes. Okay, so basically the idea here is to put a box collider around each end of the fidget spinner. Now what I would probably do is copy this component and then just add another one, and then paste component values down here, and then you should be able to just move the center of the box collider. Yeah, so this makes it a little bit easier. But yeah, you're gonna want to have obviously 3 total here. That looks about good for the box colliders. Okay, so on the topic of box colliders, I realized I forgot to add colliders to these hands. So actually go back to the assets folder and prefabs hand models, and make sure you choose those same 2 hands that we drug up into the prefab slots. So pepper, medium cut, left and right. Drag these into the scene and click on each one individually and add a box collider. Okay, that looks okay right there. And then with this prefab, make sure you hit apply or it's not going to save. So we got one on the right. Let's do the same thing for the left. Okay, so that looks okay. Don't forget to hit apply. And then remove both of those hands from the scene. Okay, so let's go back to our fidget spinner, and we're pretty much actually ready to go. However, whenever you actually hit these fidget spinners, they don't spin very fast, so we're gonna have to do a little scripting here and work some magic to get them to actually spin a little bit more than they would normally. So inside the assets folder, create a C# script and just call it fidget behavior. And then make sure to click on your fidget spinner and drag this script onto the fidget spinner. Double click it to open in MonoDevelop. So the main problem here, not only do these fidget spinners not spin that fast on their own, but they also tend to move around when you keep trying to hit them with your hands. So the first thing we're going to do is we're going to make sure that the fidget spinner stays in place. So go private vector 3, and let's call this original position. Okay, remind me tomorrow. Alright, in the start function, let's go original position equals transform.local position. And then in the update function that gets called every frame, we are just going to basically force the position to stay the same. So transform.local position equals the original position. Now the second thing we're going to do is we're going to basically force the fidget spinner to only spin about its z-axis. So I forget what our x angle was, so let's go float, just call it x angle. And then in the start function, let's go x angle equals transform dot let's go transform dot Euler angles dot x. That'll save our x angle, and then we're going to basically do the same thing with rotation. So we're going to transform dot Euler angles and set that equal to a new vector 3, which is x angle, and then y was just 0, I believe. We didn't touch that, but then we do want to allow the z angle to spin, so transform.Euler angles.z. Alright, so we should be good there. Now the last thing we need to do is to kind of force the fidget spinner to spin a little bit faster. So what worked for me was going, let's first create basically a reference to the rigid body. So private rigid body, and let's just call it RB. Let's get the reference in the start function, get component rigid body. And then this is how we're going to do it. So void on collision exit. Okay, so void on collision exit and pass in a collision. And just call it COL. And then what we're going to do is add force to the rigid body at the transform.position of the collision. So that way, when the colliders are exiting each other, it's going to add extra force at that position and hopefully cause our fidget spinner to go a little bit faster. If we go back to our scene here, we only have one fidget spinner in there for right now. So let's actually copy and paste this and just do a bunch of them. So just duplicate these a couple times and move them however you see fit. Alright, so that looks about good. If you are on Android, you should be able to just go build and run. But since I'm on iOS, I need to go to player settings and let's see, bundle identifier. I need to put in something for my bundle identifier. So com.myname. I don't know, fidget test VR. Okay, so everything seems to be working. If your hands feel like they're off of like the real life position, you can click the buttons on the server application. Oh, I forgot to tell you. Start the server application on your desktop, and that will allow you to, send the UDP packets of your hand position. So now, once you're doing that, if you feel like the hands like real world position is off a little bit from like their virtual position, you can click those like left and right buttons to change like the X, Y, and Z offset for each hand, and they'll kind of update in real time. It'll be easier to see the offset actually when we build it out for AR, but for right now, it seems like this is working pretty decent. The only problem is I put the fidget spinners up definitely way too high, so I'm not going to build this out again, but yeah, I don't know if I can I reach them? Oh yeah, I can reach those top ones. Alright, let's get this working for AR. Okay, so let's get this working for AR now. We really don't have all that much work left to do. Let's delete all these fidget spinners. We're only going to do one for this AR demo. Oh, we have to create our hands. This was difficult for me. I almost didn't do this video because I couldn't figure out a way to represent hands in AR. It's actually like kind of a hard problem because of occlusion. When you turn your hand sideways, the cube always is displaying in front of your hand. It never, gets occluded by your hand. So it really doesn't look good, but it's the only way I could think to do it. You don't necessarily need the cubes that I used in the demo in the intro, but it helps to know like when your hand is tracking, and it helps to know exactly where the collider is when you're trying to hit things. So we're going to stick with that for right now, but if anybody, you guys will probably come up with a better solution, but I don't know one as of right now. So let's create a cube, and this is what we're going to use to represent our hands. So change the scale to let's go 2 and 0.5 and 2. Drag this into the assets folder, and it'll make it a prefab. Delete the one from the scene. Go to your hand controller, and then just drag a cube in for each of the hands. Oh, before I forget, let's go to the AR camera, open Vuforia configuration, enable video background. That's what we want. And then let's go to assets, prefabs. Oh, sorry, we need to go to Vuforia. Okay, Vuforia, prefabs, there it is. And drag the image target into the scene. Okay, and then let's drag the fidget spinner to as a child of the image target. I actually wrote down the positions that I used because I don't want to have to build this out multiple times. So let's just stick with the positions I know work. So let's go negative 1.219 for the X. And let's go 0.62 for the Y, and 0.14 for the Z. The idea here is to get the fidget spinner away from the image target. Oh, you know what? Let's delete our ground for now. So you'll see the white thing here represents our image target. The idea here is to get the fidget spinner kind of offset from our image target so that when we're playing with it in AR, if our hand gets in front of the image target, which we're going to put up on our computer screen, then we'll lose tracking. So we don't want that to happen. So we want to be able to like kind of play with the fidget spinner, but also our camera on our phone, we want it to have a clear view to the image target. So let's do that. So we got the position correct. As for the rotation, set the X rotation to 145. Let's go 0.02. We need it to be a little bit smaller. I think, I hope that this will work. So let's build it out and let's see what happens. Okay, so I built out and it did not work. I think I forgot two things. In camera, go under clear flags, change skybox to solid color. Also, on image target, I forgot to load the image target database. So with the image target selected, database, fidget spinner database, fidget design, that should be it. All right, let's try this one more time. All right, so put your phone in your VR headset, expose the camera, go to the fidget stuff folder and pull up the fidget design JPEG. And if you look at this, you should see a fidget, oh crap. Okay, you'll see the fidget spinner, but I forgot to do something with the directional light in the scene. You could either remove it and make this model like kind of vertex lit, or just uncheck cast shadows on the fidget spinner model. So sorry about this, but I don't have enough. I don't want to go back and build this again. So let's minimize this for now and open up the desktop application, and let's see if we get hands. Okay. We do. Now you'll see that there's an offset here. Oh no. This looks okay. So if your square is off, you can like check these buttons and move it around accordingly. But this actually looks okay. This could be like my old data. I have this server application set to like save your offset locally to like your player preferences. So once you set the offset once, you shouldn't have to set it again. Let's test this out. Now, you have to be careful, at least on my Mac, even though in the build settings of this server application, I have it set to be able to run in the background, it still won't run in the background for some reason. So this server application has got to be on the foreground. So pull up your image target, but then make sure this is actually in front of it, or else your hands won't track. So let's see, you should be able to hit this thing and spin it a little bit. Cool. It's working. Oh man. This is not working very well for me at all because, like I said, I'm screen recording right now and my computer just wants to kill me. Actually, I'd love to see people making this. I never get to see anyone like making these projects, so if anyone does make this, definitely tag me on Instagram or something. My Instagram name is Matthew Hallberg. Find me on there and tag me. I'd like to see what some people make with this. But all right, so that's it. That's all I got. Like this video if it helped you out at all, and definitely let me know in the comments what you guys want to see in the next video. Good night.